In this video, elastic collision was happened. The object 1 moves and collides with object 2 who is at rest. What is their movement after the collision? After collision, the speed of the object 1 decreases and the speed of the object 2 increases. Momentum of the object 1 decreases and momentum of the object 2 increases.
Collision happens when two or more objects come into contact with each other and a transfer of momentum and kinetic energy occurs. Collision occurs every time you hit a basketball, bounce a basketball, or play pool. When objects collide in the absence of external forces, they form a system in which the net momentum of both before the collision equals the net momentum of both objects after the collisions. There are two types of collisions: elastic collisions and inelastic collisions. An elastic collision is defined as one in which no kinetic energy is lost, no damage is done to the objects involved, and there is no generation of heat.
However, the game of pool offers a fairly good elastic representation. When the cue ball hits the resting egg ball, it sets the egg ball in motion. Having transferred all of its momentum and kinetic energy, the cue ball comes to at rest. The net momentum of the cue ball before the collision equals the net momentum of the egg ball after the collision. Momentum and kinetic energy are transferred and conserved. If the egg ball is already in motion, when a similarly moving cue ball collides with it, then the egg ball will gain some of the initial cue ball's momentum, and the net momentum before and after the collision will be conserved. If the egg ball and the cue ball are traveling at the same speed and collide head-on, then they will bounce off each other with the same momentum but in opposite directions. Their momentum and kinetic energy are transferred and conserved.
Hello guys! So today, I would like to share one simple question for this topic. First of all, before we start answering the question, this is some tips to get correct answer. First tips is carry the habit of sketching the situation before and after the collision. This is because some question does not give the pitch, so you have to imagine it. It will be easier for you to answer it. Next, after you finish your sketching, label your sketch with all the variables and information that you get from the question. And lastly, more important thing is to make sure that you are constantly ensuring that the sign of your vector or direction is consistent. If the object is moving to the left, then you have to put negative sign. And if the object is moving to the right, then it will be a positive sign. Let's take a look for this simple question. Okay, in this question say that car A of mass 1000 kg moving at 20 meter per second collides with car B of mass 1200 kg moving at 10 meter per second in the same direction. If car B is shunted forward at 15 meter per second by the impact, what is the velocity v of car A immediately after the collision? Okay, before answer the question, let's apply the tips that I mentioned just now. For the first step, you have to sketch the situation from the question. So, in this question, it have car A and car B. Next, label your sketch with all the variables and information given from the question. Okay, the mass for car A is 1000 kilograms and the mass for car B is 1200 kilograms. Car A are moving at 20 meter per second. Meanwhile, car B is moving forward at 10 meter per second. Okay, these are the information that we got from the question before the collisions. After the collisions, car B is shunted forward at 15 meter per second by the impact. The question is, what is the velocity v of car A immediately after the collisions? Before answering this question, please make sure that you use the correct equation. For this question, we use this equation, which is total momentum before collisions are equal to the total momentum after collisions. Then you can just apply the information that you get from the question into this equation, like this. Okay, done! Bye! I hope you guys understand.
Feeling good, like I should. When in dark,